Hello everyone, welcome to the next video of C programming. In this video, we'll discuss a very interesting concept known as your dynamic memory allocation, or in short, it's a DMA. Now, DMA is actually the solution to a lot of problem of in C programming. Now, what do you mean by DMA? So, DMA comes from memory allocation. Now, before understanding what is dynamic memory allocation, let us understand what is memory allocation. Now we know that it's a process of nothing but reserving and managing different types of memory for a program's variable and data. Because whenever you are writing some programs, you are using variables, you are storing some data, but where actually the values will be stored, how the variables are getting memory inside the memory location. So all those things, managing and reserving the process of memory, is known as your memory allocation. Now, if you'll discuss, there are basically two different types of memory allocation mechanisms are available. One is a static memory allocation. Second is a dynamic memory allocation. Now, whenever you are talking about the word static, means it's fixed, and dynamic, which is not fixed. Now, how you'll find the difference between these two types of memory allocation? Okay, so we'll see what is actually the difference between these two types of memory allocation. Okay, now we'll come to these points later. Let us see one example ki how actually the values are or the concepts are different. Okay, so the memory allocation that we have done till now was static memory allocation. Means what? The memory that could be used by the program which is fixed. The first keyword we have coined is fixed. So that means in static memory allocation, the memory allocation is fixed. That means what? We could not allocate or deallocate memory during the execution of the program. Okay. In many applications, we have seen that it is not possible to predict how much memory actually required by the program at the runtime. Okay. Like for example, suppose we are managing the attendance of a particular class. Okay. So let's consider 200 total students are there in this class. Okay. So how to allocate the memory? Now, obviously, we have to declare one array where I have to write integer roll number of 200. Okay. So that means we have to take the help of an array because we can store multiple values in a single variable. Okay. But what problem we are actually facing? So in an array, it is must to specify the size of array while declaration. Okay. So the size of this array will be fixed during the runtime. Okay. So again, we are coming to that position that the size is always fixed. Okay. Now, if the size will become fixed, we'll face two different types of problems. Problem one and problem two. Okay. Now, what is the first problem? The first problem is what? The number of values to be stored is less. That means I need to store some less number of students. That means in this year, suppose around you can say 50 students have taken admission. Okay, 50 students are available for the class. So that means out of 200 blocks, only 50 blocks I'll use. Rest what happens? 150 blocks, and as the size is integer, the size of integer will be 4 byte. That means 600 bytes of memory wastage are there. Okay, that is problem one. If my requirement is less, then memory wastage will be there because during the time of declaration, I have fixed the size of the memory. Okay. Second problem. Suppose this year around 210 students have taken admission. Now how I will manage because I cannot exceed the size. Okay. So that means if my need is more, then I cannot extend the memory size. If my need is less, then I cannot squeeze the memory size. Okay. So for that, these two problems, to overcome these two problems, we should be able to allocate or deallocate the memory at the runtime because my requirement will always come during the execution time or runtime. You are writing a program, addition of two numbers. Which two number you will provide for addition? Whenever you are executing it is asking for enter two numbers. Then only you are thinking which two numbers I'll provide for addition. It is not like कि while writing the program or before writing the program, you have fixed your mind कि I have to add 10 and 20. Never. Whenever you will execute, the command prompt will ask you enter two numbers. Now, whatever the first two numbers are coming to your mind, that you are adding. Okay, so that means there should be a possibility or there should be some flexibility that I need to allocate or release the memory space which is required at the time of execution. Okay, and because of these things, the dynamic memory allocation concept have come. Okay, now let us see point by point what is the meaning of static memory allocation. Let me remove all those things. Okay, now you check. Static memory allocation means which is allocated during the compilation time. Okay, so during the compilation time we have fixed because at the time of declaration you are telling okay, I have allocated my memory. So if you have allocated the memory during compilation time, that means that is declaration time. And second thing is what? Fix the size. And the example we have seen is array. What is the problem? Problem is wastage or lack of memory. So the solution is nothing but it's a dynamic memory allocation because you are not allocating or you are not fixing the memory during the compilation time. You are giving the space during the execution time. Also, you are providing the flexibility. That means you can allocate, you can deallocate during the execution of the program. So as per your requirement, your memory will be allocated. So if you will go with this particular solution, definitely there will be no wastage of memory or there will be no lack of memory. Why? Because as per my requirement, my memory will be allocated. Okay. Now, whenever we are coming to dynamic memory allocation, how actually we are going to achieve this? Now, this is required when you don't know. This is very important. When you don't know how much memory is actually required beforehand, then you must go with dynamic memory allocation because you don't know how you'll allocate the memory during the compilation time or how you'll fix the allocation during the compilation time. You have to go for dynamic memory allocation because you don't know how much memory is required. Okay, and all those things can be achieved by using four different types of functions in dynamic memory allocation. One is malloc, second calloc, third is realloc, and fourth one is a free. Okay, so that means we are using two different types of functions to allocate memory. One function you are using to adjust the memory means the reallocation of the memory, and the fourth one we will use to deallocate the memory whenever it is required. So that means you are not wasting any of the memory, you are allocating as per your requirement, also you are deallocating as per your requirement through the concept of dynamic memory allocation. Okay, so as per our discussion you have already realized how interesting the concept will be. In the next video you will see the applications or the functions, use of functions, and also we'll write down the programs by using dynamic memory allocation functions. Okay, so thank you everyone for watching this video.